Hello my friend and welcome to my channel Zip. I hope that you are well. So I talked about the JavaScript engine in the last video, but what is that engine actually? And what is JavaScript runtime? And also, how is JavaScript code translated to machine code? So that's just some of the topics that we talked about in the last video. And so now, let's find out how they work in this video. So, JavaScript engine is simply a computer program that executes JavaScript code. There are a lot of steps involved in doing that, but essentially executing JavaScript code is what an engine does. Now, every browser has its own JavaScript engine, but probably the most well-known engine is Google V8 engine. The V8 engine powers Google Chrome, but also Node.js, which is that JavaScript runtime that we talked about in the beginning of the course, so the one that we can use to build server-side application with JavaScript, so outside of any browser. And of course, all the other browsers have their own JavaScript engine, which you can look up online if you are interested. Anyway, it's quite easy to understand what an engine is, but what's most important is to actually understand its component and how it works. So, a JavaScript engine always contains a core stack and a heap. Okay? The core stack is where our code is actually executed using something called execution context. Then the heap is a structured memory pool which stores all the objects that our application needs. Alright, so with this look at the engine, we have answered where our code is executed. But now the question is how the code is compiled to machine code. So what is so that is actually can be executed afterwards? Well, let's find out. But first, we need to make a quick computer science side note here and talk about the difference between compilation and interpretation. So, in the last video, we learned that the computer's coprocessor only understands 0 and 1s, and that therefore every single computer program ultimately needs to be converted into this machine code. And this can happen using compilation or interpretation. So, in compilation, the entire source code is converted into machine code at once. And this machine code is then written into a portable file that can be executed on any computer. So we have two different steps here. First, the machine code is built and then it is executed in the CPU, so in the processor. And the execution can happen way after the compilation, of course. For example, any application that you are using on your computer right now has been compiled before and you are now executing it way after its compilation. Now, on the other hand, in interpretation, there is an interpreter which runs through the source code and execute it line by line. So here we do not have the same two steps as before, and still the code is read and executed all at the same time. Of course, the source code still needs to be converted into machine code, but it simply happens right before it is executed and not ahead of time. Now, JavaScript used to be purely interpreted language, but the problem with interpreted language is that they are much slower than compiled language. This used to be okay for JavaScript, but now with the modern JavaScript and fully fledged web application that we build and use today, low performance is no longer acceptable. Just imagine you are using Google Maps in your browser and you were dragging the map, and each time you drag it will take the second for it to move. That would be completely unacceptable. right? Now, many people still think that JavaScript is an interpreted language, but that's not really true anymore. So instead of simple interpretation, modern JavaScript engine now use a mix between compilation and interpretation, which is called just-in-time compilation. This approach basically compiles the entire code into machine code at once and then execute it right away. So we still have two steps of regular heat of time compilation, but there is no portable file to execute. Okay? And the execution happens immediately after compilation. And this is perfect for JavaScript, as it is really a lot faster than just executing code line by line. Now, I skimmed over some details here, but this is really all you need to know. Anyway, let's now understand how this works in the particular case of JavaScript. So, as a piece of JavaScript code enters the engine, the first step is to parse the code, which essentially means to read the code. During the parsing process, the code is parsed into a data structure called the abstract, syntax tree, or AST. Okay? So, this works by first splitting up each line of code into pieces that are meaningful to the language, like the constant or function keywords, and then saving all these pieces into the tree in a structured way. This step also checks if there are any syntax errors, and the resulting tree will later be used to generate the machine code. Now, let's say we have a very simple program. All it does is to declare a variable like this, and this is what the AST for just this one line of code look like. Okay? So we have variable declaration, which will be a constant with the name x and the value of 23. Okay? And beside that, there is a lot of other stuff here, as you can see. So just imagine what it would look like for a larger application. And of course, you don't need to know what an AST look like. This is just for curiosity, okay? Now, sometimes I get asked if this tree has anything to do with the DOM tree, and the answer is very clear now. No. So this tree has absolutely nothing to do with the DOM. It is not related in any way. It is just a representation of our entire code inside the engine. Okay? Anyway, the next step is compilation, which takes the generated AST and compile it into a machine code, just as we learned into the previous slide. The machine code then gets executed right away because remember, modern JavaScript engine use just-in-time compilation. And remember, execution happens in the JavaScript engine call stack, but we'll dig deeper into in the next video, inshallah. Okay? Alright, so far so good. We have our code running, so we can finish here, right? Well, not so fast, because modern JavaScript engine actually have some pretty clever optimization strategy. What they do is to create a very unoptimized version of machine code in the beginning, just so that it can start executing as fast as possible. Then, in the background, this code is being optimized and recompiled during the already running program execution. And this can be done most of the time, and after each optimization, the unoptimized code is simply swapped for the new, more optimized code without ever stopping execution, of course. And this process is what makes modern engines such as the V8 so fast. Okay? And all this parsing, compilation, and optimization happen in some special thread inside the engine that we cannot access from our code. So completely separate from the main thread that is basically running into core stack executing our own code. Now, different engines implement in slightly different ways, but in a nutshell, this is what modern just-in-time compilation looks like for JavaScript. And the next time someone tells you JavaScript is an interpreted language, you just show them this slide so that they can learn how it really works. Okay? Alright, so we looked at the JavaScript engine and how it works behind the scene in quite some detail. Now, to round off this video, let's also take a look at what JavaScript runtime is. And in particular, the most common one, which is the browser, and by doing this, we can get the bigger picture of how all the pieces fit together when we use JavaScript. And so this is really important slide. So we can imagine a JavaScript runtime as a bigger box or a big container, which include all the things that we need in order to use JavaScript, in this case, in the browser. And to heart of any JavaScript runtime is always JavaScript Engine. So exactly the one we have been talking about. That's why it makes sense to talk about engine and runtime together. Without an engine, there is no runtime and there is no JavaScript at all. However, the engine alone is not enough. In order to work properly, we also need access to the Web API. And we talked about the Web API before, remember? So that's everything related to the DOM or timers or even the console.log that we use all the time. So essentially, Web API are functionalities provided to the engine, but which are actually not part of the JavaScript language itself. JavaScript simply gets access to this API through the global window object, but it still makes sense that the Web API are also part of the runtime, because again, a runtime is just like a box that contains all the JavaScript related stuff that we need. Next, a typical JavaScript runtime also includes a so-called callback queue. This is a data structure that contains all the callback functions that are ready to be executed. For example, we attached event handler function to DOM element, like a button to react to certain event, right? And these event handler functions are also called callback functions. Okay? So as the event happens, for example, a click event, the callback functions will be called. And here is how that actually works behind the scenes. So the first thing that actually happens after the event is that the callback function is put into the callback queue. Then, when the stack is empty, the callback function is passed to the stack so that it can be executed. And this happens by something called the event loop. So, basically, the event takes callback functions from the callback queue and puts them into the call stack so that they can be executed. And remember how I said in the last video that the event loop is how JavaScript non-blocking concurrency model is implemented. Well, here is an overview how that works. Now, we will go over why this makes JavaScript non-blocking in a special video about the event loop later in the course, inshallah, because this is really a fundamental piece of JavaScript development that every developer needs to understand deeply. Alright, so as they already say, the focus in this course is on JavaScript in the browser, and that's why we analyze the browser JavaScript runtime. However, it's also important to remember that JavaScript can exist outside of browsers, for example in Node.js. And so here is what the Node.js JavaScript runtime look like. It is pretty similar, but since we don't have browser, of course, we can't have the Web API. Okay? Because it's the browser who provides this. Okay? Instead, we have multiple C++ binding and so-called thread pool. No details No, details don't matter here at all. I just want you to know that different JavaScript runtimes do exist. Alright, cool. That's all I had to tell you about JavaScript Engine and runtime. In our next video, inshallah, we'll learn how JavaScript is executed in the call stack. So take care of us, and sisters. Don't forget to subscribe to my channel, Faisal Azib, and follow me on Instagram, faisal.chico. I tell you goodbye. Wassalamu alaikum wa barakatuh.